Hello everyone. Welcome to the solution of LeetCode problem 392 named is subsequence. In this problem, we are given two strings which is S and T, and we have to determine whether S is a subsequence of T or not. If S is a subsequence of T, then we have to return true, otherwise we have to return false. Now, let us understand the definition of subsequence. The definition given here is little bit of complex, and I think most people will face some trouble while understanding it. Anyways, in mathematics or computer science, a subsequence of a given sequence is a sequence that can be derived from the given sequence by deleting some element or no element without changing the order of the remaining element. I know the definition is a little bit of complex. Anyways, let's try to explore the example 1, and I think you will understand what is the subsequences. Here, in the first example, the value of S is ABC, and the value of T is AHBGDC. Now, we can say that ABC is a subsequence of AHBGDC. Why it is? Because at first we found A in the S. Now the first letter of T is also A. So we have found a match. Anyways, the second character of input S is B, but the second character of T is not B, which is H. Now we have to move forward. The third character of the string T is B, so we have found another B here after A. Now, the third character of input S is C, and the fourth character of input T is G, and fifth character of input T is D. Anyways, both of them are not equal C. Then after it, we have to move to the last element, which is C. Then we can find a match with the last character of S is equal to the last character of T. So we can say that S is a subsequence of T. Now, in the second example, the first string is AXC and the second string is AHBGDC. Here we can see that in the first example, there is an element named X, but in the second example, there is no X. So we can say that S is not a subsequence of T. Now, I hope you understood what is subsequence. Now let's move on to the constraint. Here, the string length of the first string is 0 to 100, and the length of the last string can be in between 0 to 10 to the power 4. And it is ensured that both first and the second string only contain the lowercase English characters. I hope you understood the problem. Now let's see how can we solve this. At first, we are given two strings, and we have to determine whether the first string is the subsequence of the second string or not. If it is, then we have to return true. Otherwise, we have to return false. Now, we are taking a pointer, which name is index, INDX here, and it will point to the first character of the first string, which is now pointing towards the A. And in the second string, we will use a for loop to iterate from the first character to the last character. Anyways, in each iteration, our current element I will point to the corresponding character. At first, our I is pointing to the first index, and the value of the first index is A. So now we have to check if the value presented in index is equal to the value presented in I. And we have clearly seen that this A is exactly equal to this A. In this case, we have found a match. Now we have to update our index pointer to the second element of the first string. Now our index is pointing to the element B, and our current I is now pointing to the element H. But B is not equal to H, so we did not find any match. In this case, we will not upgrade the value of index. We will update the value of I. Now, our I will point to the third element, which is B. And we have clearly seen that this B is exactly equal to this B. So we have found a match. In this case, we have to update our index and the I as well. So in this case, we have to update both of the index and I. Now, our index is pointing towards the element C and our I is pointing to element G. But we have clearly seen that C is not equal to G. So we did not find any match. In this case, we have to update our I. Now, I is pointing towards the next element, which is D. And index is still pointing to third element, which is C. And in this case, we have seen that D is not equal to C. So we did not find any match here. So in this case, we have to upgrade our value of I as well. Now, our current I is pointing towards the last element, which is C. And we have found a clear match because the value pointing index, which is C, exactly equal to the value pointing I, which is also C. Now, as we find the match, we have to update our both pointer. Now, our pointer index is pointing to the index 3 and our I is pointing to the index 6. And we have completed the iteration. So as we clearly see that we have found C here, we have found B here, and we have found A here. So we can say that first string is the subsequence of the last string. So in this case, we have to return true. So what is the condition? The condition is we will always check if the value of index is equal to the size of the first string. If we find all the matches, then our index value here is 3 and the given input is ABC and the length of them is 3. So we can say that the value of index is equal to the length of the first string. If the value of index is equal to the length of the first string, then we can say that first string is the subsequence of second string. I hope you understood the algorithm. Now let's move on to the code. In this code, we are given a function which is subsequence. The return type of this function is Boolean because we have to check whether first string is the subsequence of the second string or not. If it is, then we have to return true. Otherwise, we have to return false. And the parameter is given, which is string s and string tree, which is both of the string. At first, our index pointer is pointing towards the first element of first string, which is 0. The index is 0. Now, we have to run a for loop from 0 to the length of the second string. And in each iteration, we have to check a condition, whether s of index is equal to t of I. If it is, then we have to increment our index value. And at first, we have to check whether our index value is equal to the length of the first string. If they are equal, then we have to return true. Otherwise, we have to return false. I hope you understood the code. Now, let's move on to the time and space complexity analysis of this problem. In this program, the time complexity is big O of n because we have to iterate the second string. And let's assume the length of the second string is n. So the time complexity here is big O of n. But the space complexity of this program is big O of 1 because we are not taking any extra memories. We have just taken a pointer index and we are comparing the value. So that space complexity of this program is big O of 1. Thank you everyone for watching this video. We will get back soon with another LeetCode solution.